we go. Okay. So I'm going to write y is approximately 0.0119 x squared minus 0.308. The 5 is followed by a 7, so I'm going to round that to 6x. And then for the c, I'm just going to write this down first because they actually gave me the answer to c in scientific notation. That's what the E means on your calculator. Is that familiar to you guys? Have you seen that before? Yeah? Okay. So down here, I'm going to convert it. So if they've written negative 4.761905 E negative 4, that E really means times 10 to the negative 4th. That's what the C means when it says E negative 4. It means times 10 to the negative 4th. So if I want to convert this to not being scientific notation anymore, do you guys remember when your scientific notation has a negative number, which way the decimal is supposed to go? It goes to the left. It makes the number a smaller decimal instead of making the number a bigger, like, whole number. So I'm going to take my decimal and I'm going to move it 1, 2, 3, 4 places to the left. I'll take my negative sign and move it to the front of that. 0, 0, 0. All right, so I've got minus 0.000, and the 4 is followed by a 7. So I'm going to put 0.0005. Does that happen very often? No, to be honest. I haven't seen that a ton. So that was it was a good example problem, but I don't see it all the time. Okay, I'm going to write down my r squared. This one, it has 5 9s in a row, and so I'm going to go ahead and just put 5 9s there instead of rounding to 4 decimal places on this one. I don't want to round it up to 1 if it's not actually a 1. Okay. Are we comfortable with that so far? Yeah? Okay. Now it says, so we're going to take this equation. Let's go ahead and graph it actually so we can see it. So hit the graph button. All right. So it says from here, they want us to take this equation for part B, and they want us to predict the change in the finishing time. So this is a problem about track. And they said positive wind speeds correspond to tailwinds, negative wind speeds correspond to headwinds. So they're just talking about, like, if you're running, if the wind is like in your face, if it's against you and it's slowing you down, or if the wind is behind you and it's pushing you forward. And then they are talking about if it's making the runner's time longer, which would be a bad thing, right? You don't want your time to be longer, you want your time to be faster. Or if it's decreasing your time, which would be beneficial to you, because your time would be faster overall. So the change in the finishing time is the difference between the runner's time when the wind speed is, they did S and T. Let's fix this in here. They did T for time instead of X values. T for time. And then they did S for their speed. The wind speed. Okay. The runner's time when there is no wind. Okay. So this was no wind. Okay, so they said to predict the change in the runner's finishing time when the wind speed is 10 meters per second. 10 meters per second is not on this table. So we have two ways the calculator can help us. 10 meters per second, it's nice of them to give us a whole number to plug in because we can just take the calculator and we can look at the table. So we could do second graph and look at the table and scroll until we find the 10. And then we would say, okay, if the wind is 10 meters per second, then that should shave 1.896 seconds off of their time. We can just look at that from the table. If they had asked us to plug in a decimal, we would not be plugging that into the table. We would have to plug it in using a different method. Okay, so I'll show you that in a second, but let's go ahead and write this down. If we're doing a story problem like this, then story problems deserve story answers. So we're going to answer this in a sentence. Okay, so we're going to say when the wind speed is 10 meters per second, when the wind speed is 10 meters per second, the change in finishing time is negative 1.896 seconds. And here it's okay for us to use a negative number in a sentence because of the context of the problem. They're using positive time to say it's adding to your time. They're using negative time to say it's taking away from your time. So in the context of the problem, it makes sense to have a negative in the sentence. Okay. Now, if they wanted us to say if the wind speed is like 10.2 meters per second, we couldn't find that from the table since the table only has whole numbers. And so the way that we could plug in some other values is we can use the calculator to calculate those values for us. Right up here, we can see calculate in blue. So we can only calculate values that are on the screen. So if you guys remember, when I hit the window button, the X values that we had on the screen were from negative 7.2 to positive 7.2. So I can only plug in values for the wind that are between negative 7.2 and positive 7.2. So if I wanted to plug in a wind value of like 10.2, I would not be able to do it right now because my window's too small. So if I wanted to plug in something bigger, I just need to make this window a little bit bigger. If I turn this into 12, I can hit graph again. And now I could use the calculator to calculate some bigger values for me. So if I hit second calculate, then option number 1 lets the calculator do some values for me. So I'm going to press number 1, and it says, all right, what X value would you like me to plug in? I would like the calculator to plug in 10.2 for me, and then it just plugged in 10.2 for me. Or I can ask it to plug in 5.6, or negative 1.7, or negative square root 3. It can plug in any number that I want, any decimal that I want. It just has to be one of the X values that's currently within that window. If I ask the calculator to plug in 20, it's not going to plug in 20 because 20 is bigger than the window that I have. Does that make sense? So once you have your equation, you've got it plugged into the calculator can find things for you using that equation. Okay, now do not delete anything. If you turn the page, for whatever reason, the notes that I got, this next problem right here, example 4, is actually the exact same problem. So we don't want to delete it. We want to keep using this same information because it's the same problem. So if we look at the r squared value that we had, 0.99999, is this a good model or not a good model? This is a really good model. So over here it says, what is the relationship between the headwinds and tailwinds and the times of the athletes? I'm going to say it's a quadratic relationship. Oops, I almost spelled quadratic wrong. Use your calculator to write a function. We already did that. I'm just going to put a check here because we already did it. Does this have a maximum or a minimum vertex? Maximum or a minimum? It has a minimum. Okay, so what does the minimum vertex represent? What does the minimum vertex represent? So think about what kind of x values would be there. Think about what kind of y values would be there. So your minimum is down here. What type of x values would we have? What type of y values would we have? We would have positive x values and negative y values. And what do negative y values mean? Say that again? It's changing the finishing time, but if they're negative, what do they mean then? How is it changing the finishing time? It's decreasing your finishing time. So the minimum, is that a good finishing time or is that a bad finishing time? If it's changing your finishing time and it's taking away from your finishing time, is that good or bad? Good. So the minimum would be the way that the wind is impacting your finishing time to the most extreme, right? Because it's the minimum, it's an extreme point. It would be the way that the wind speed is impacting your finishing time the very most. It is decreasing your finishing time the very most. Does that make sense? The wind speed is decreasing the finishing time the very most. Okay, what is the wind speed if there is no change to the finishing time? So if we look, you can see this from the table. You don't need our equation to do it. If there is no change to the finishing time, then there's no wind speed. The wind isn't working for you. The wind isn't working against you. It didn't change your finishing time. It's just however fast you happen to run. Does that make sense? Didn't work for you, didn't work against you. It's just however fast you run. Okay. The next one says, predict the change in your finishing time if your wind speed is -1. What about if your wind speed is 5? So -1 and 5 are both not on this table, but they are going to be on the table on our calculator. So you have two ways of checking those numbers. You can do second calculate, and you can plug in -1 and -5 using the first option. So we could plug in -1, we could plug in 5. Or we can do second graph, and we can look at -1 and we can look at 5 using the table here. Okay? So use one of those methods to find those two values. So we're going to plug in -1, we're going to plug in 5. Okay? So take a moment, let's go ahead and do that. I'm going to say the function, we said that the function was s equals. So I'm going to take the function, I'm going to plug in -1 first. And I'm going to say what it equals. So if I use the table, plug in -1.32. And then for the other one, I'll go ahead and do it the other way. So with this one, I'll do second trace to calculate, option number 1, and I'll plug in 5. All right. How are we feeling about this one? Pretty good? When you're done with that problem, go ahead and clear your calculators. All right, so example 3. What is the first thing we do on our calculator? Before we clear, or after we clear it? We hit the mode button. And we gotta do what? Yeah, turn on the stat diagnostics. And what does that do? Turns the r squared on so we can see how accurate our equation is. Okay? Now what do I do? Hit the stat button. I'm going to edit so I can plug in my list of numbers. Okay. 15, 20, 25, 30. And we double check, make sure we don't have any typos. And we need those points to be graphed. How do we graph those points? Second y equals, so these are going to look like a scatter plot. So we're going to hit second y equals. Look at scatter plot 1. And we turn it on. And then our default window from -10 to 10, that's not going to work. So how do we change it? Hit the zoom button. And number 9 is what's going to change that for us. Okay, so here's our parabola shape. So now I want to get my equation. How do I do that? Stat button. I'm going to calculate the equation. Go down to number 5. I'm going to press enter. So it's using list 1 for the x value, list 2 for the y value. I want it to graph my equation for me. How do I do that? Before calculate, I do alpha trace, and that's where I'm going to get my y1. That's going to take the equation that I calculate. It's going to plug it back in for me so I can graph it. So I'm going to press enter. And now I can press enter again and let it do the calculation. Okay, so let's go ahead and write down the values that we got. Some worksheets will ask you for the r-squared just to see how accurate it is. Some of them won't. This particular worksheet has not asked us for it, but it's often good to write it down just so you know. Say it again? If you didn't need it? You didn't get it? If you didn't get it, it's because you didn't hit the mode and turn the stat diagnostic on. Yeah. Good question. Okay, we all got our equation? All right, so what does the quadratic function represent in terms of gas mileage and speed? It's just talking about how the speed impacts your fuel economy, so how the faster you drive, if you drive super slow in neighborhoods or if you drive super fast on the highway, then your gas mileage goes down. When you do that, like, set your cruise control at 55, 60, that's when your gas mileage is the best. That's what it's talking about.
I never understood that. Because, like, in my car, it, like, shows me, like, it'll go up and down, like, the faster or slower I go. And I've never understood that.
Yeah, so it's when you're in neighborhoods, you do a lot of speeding up, slowing down, stopping, going, so that uses your gas. And then when you're driving really fast highway speeds, you can see that your car's working harder. Versus when you're sitting there at like a constant 60, your cruise control is set, that's your car is not working very hard. So that's like the coasting idea. Yeah. Okay, so we don't have to write a ton for that. That's just talking about how your variables are relating to one another. All right, so this says find the speed. The speed is the x value. Find the speed that maximizes the fuel economy, that's the y value. If it says the word maximize, then that should make you think of the maximum, which is the vertex. So if we're going to graph this, we can see there's a negative in the very front. If we're going to graph this, we're going to see that this is an upside down parabola and it's going to have a vertex up here. I can tell that just because there's a negative in the front. So if I go ahead and I hit graph right now, there's my points. I have an upside down parabola. Then whatever point I have right up here at the maximum, that's going to be the speed that is going to maximize my fuel economy. If I want to get the most bang for my buck in the case of like how much I'm paying for my gas, and not wasting my gas, it's going to be whatever speed is up here that corresponds to this point. Does that make sense? Okay, so it says where is it located graphically? It's going to be at the vertex or the maximum. You can call it either of those. It's the same point. So let's go ahead and let's figure out what that point actually is. So when we find this on the calculator, we are calculating it. So I'm going to do second trace. And I'm going to be doing the maximum. The maximum. Now, you can scroll left and right on this if you want. You can do left bound, right bound, and scroll left and right. But I know that the smallest x value for my data is 15, and the largest x value for my data is 70. So if you just want to tell your calculator, look for a maximum between 15 and 70, your calculator will find it. So if I want to say for the left side of my maximum, use 15. For the right side of my maximum, use 70. My calculator can calculate it for me based on that, and I don't have to scroll to the left and the right. Okay? So the way that I did that is I did second trace, option number 4 for maximum, and then when it said left bound, instead of me holding down my left arrow and trying to get it to the left side of the mountaintop, instead of doing that, I typed the number 15 and I pressed enter. And then instead of holding down my cursor to get to the right side of the mountaintop, I didn't hold down my cursor to do that. I just pressed the number 70 and pressed enter. The guess is always dumb. I always ignore the guess. And I just press enter one more time. And it finds the maximum for me, that vertex for me. So whenever your calculator asks you to do like a left bound, right bound to find an answer, you can either use your arrows to go back and forth, or you can type the numbers to go back and forth. So I'm going to go ahead and write down what this point is. This is 45.4988. 45.4988. And then 30.4407. Okay. So it's the vertex. If the question is phrased as find the speed that maximizes the fuel economy, are they asking you about the x coordinate or the y coordinate? The x, because x is speed. All right, if they want you to find the maximum speed by hand, we have to go back to Math 2. Math 2 is where you learned how to find the x-coordinate of a vertex by hand. Does anyone remember how to do that? It's from the standard form. It uses the b value and the a value. Does anyone remember? It uses the b value and the a value. It's a little formula. It's a fraction. The formula for finding the x-coordinate of a vertex is x equals negative b over 2a. That's the formula. X equals negative b over 2a. That's how you find the x-coordinate of a vertex. Does that sound familiar? Not at all? No? Okay. Well, we can do it. So we already know, we've already answered the next question, actually, because we already found the vertex. So we can go ahead and write down the x value of the point, because we did that. And now we can go ahead and we can use these numbers up here. Now, this answer is going to be pretty perfect because it's using unrounded decimals. Here, we rounded to 4 decimal places. So if we plug those into negative b over 2a, it's going to mess with our answers. It's going to make our answer a little bit off. So this answer and this answer will be similar, but not exactly the same. So I'll type in negative b 0.7459 divided by 2 times a. Okay, So go ahead and type that in and see what you guys get. Negative b over 2a. So it should be pretty close to the x-coordinate we already found. The x-coordinate we already found is the perfect answer. This answer is going to have some rounding errors in it because we're plugging in rounded numbers. I'm using the a value from up here. So negative b divided by 2a. Sorry, that's my ringtone. All right, what are you guys getting? Yeah, so it's pretty close. 45.48, pretty close to 45.49, but a little bit of a rounding error. So it's not exactly the same, but it's pretty close. So we're going to say this is approximately 45.4817. Okay. Make a prediction about how much fuel you would use if you were going 42 miles an hour. So how do we plug in, if this is our graph, how could we plug in 42 miles an hour? Second trace. Option number 1, plug in 42. Okay. So I'm going to say I took the equation and I plugged in 42. And I got approximately 30.3403. Okay. So I did second trace number 1, and I plugged in 42. And then I can go ahead and do the same thing for 19. So second trace number 1, plug in 19. You could have also used the table. You could do second graph and get to the table, but to get 42, you would have had to scroll for a while to get there, and that would have been obnoxious. So second trace, number 1, plug in 19. Okay. And we go to stat diagnostics, we turn it on. Okay. We've got our table of data, so now what should we do? Hit the stat button. We're going to edit, start typing it in. Check for typos. We want to make sure we can see the points. So what do we do so we can see the points? Before zoom, scatter plot. So scatter plot's right here, so I'm going to hit second y equals. Got the plot. I'm going to turn the plot on. And then I want to make sure my window's big enough to be able to see the points. So I'm going to hit zoom, number 9. There we go. Now that I can see all the points, I want to figure out what my equation is. So how do I figure out what my equation is? Press the stat button. Go over to calculate. Number 5. It's going to use the first list for my x values, the second list for my y values. When I'm done calculating it, I want the calculator to graph it for me so that I can do something with that equation. How do I get the calculator to graph it for me? I do alpha, the green button trace. I tell the calculator to graph it into y1 for me. Press enter. Okay, so now I can go ahead and write it down. Now this one said to round to 3 decimal places. Okay. Okay. Now from here, I'm going to go ahead and hit the graph button. There, I can see it. Now, number 2, they're saying take this and find the height of the ball. So if we look at this, use this to find the maximum height of the ball. The x-coordinate is the distance. The y-coordinate is the height, right? So if I'm looking for the maximum height, I'm obviously going to be looking for the maximum. But do I want the x-coordinate of the maximum or the y-coordinate of the maximum? I want the y-coordinate of the maximum. So I'm going to find the max, but specifically I want to use the y-coordinate when I write my sentence. So I'm going to do second trace. Which option am I going to use? 4. Okay. Now you can scroll from the left to the right if you want, or you can be lazy about it and say the smallest number is 0 in the data, the biggest number is 15. So when I'm telling my calculator where to look for the maximum, I can tell my calculator to look between 0 and 15 to find the biggest number. So, hey calculator, look between 0 for my left bound and 15 for my right bound. The guess is always stupid. Somewhere between 0 and 15, there's going to be a maximum. And then from there, somewhere from there, we're going to have the maximum. I'm going to go ahead and write it down, and then I'm going to write a sentence with the y-coordinate. For my units, I'm going to use feet. I can tell that it's feet based on the table, because the table said it's in feet. When you're done, go ahead and clear your calculator. All right. How do we start the next one? Mode. Take your stat diagnostics, turn it on. Then what do we do? Stat. Edit your list. Now, the way they did this problem is pretty common. For the x value, they said this is the number of years since 1970. So for this one, that's 0 years since 1970, so that's 1970 exactly. That would make this 1980, 1990, 2000, 2010. A lot of times when they're talking about data that correlates to a specific year, they don't actually use the year itself for the x value. They have you start at a specific year and make that 0. This is very common for regression. So this is a good problem to make note of. And I would probably do exactly what I did, where I would write down the corresponding year. Because a lot of students would get the next problem, the second problem, wrong. Instead of plugging in 2020, we're going to have to figure out how many years it's been since 1970 and plug that number in. And a lot of students would plug in 2020 and then get the wrong answer. Okay, so this is a very common regression problem. Okay, we plugged in our lists. How do we make it so we can see the points? Second y equals, press enter, turn it on. How do we make it so we can see the points because the window's big enough? Hit the zoom, which number? Number 9. All right, there's our points. How do we calculate the equation? Hit the stat button, go over to calculate. Number 5. All right, using our x values, using our y values. How do we make it so the calculator is going to take our equation and graph it for us? Alpha trace, press enter. Okay, and then let's go ahead and actually calculate it. All right, again, rounding to 3 decimal places. So y is approximately 1.209 x squared plus 12.99. The 8 is followed by a 5, so I'm going to round that up. Okay. So for the next question, in 2020, how many years has that been since 1970? 50 years. We need to plug in 50 for x. Before I do that, I look at the window. And if you look at the window only goes to 44. So I can't plug in 50 if the window only goes to 44. So I'm going to go and I'm going to take the window, I'm going to change it so it goes at least to 50. So I did that in the window button, window right here. That's where I'm changing it to 50 for the max of the x value. And then I'll graph it again. It's going to look about the same. It's a little bit bigger. And now I can hit second trace. For option number 1, I can find the value of the function when I plug in 50. Now, I followed their lead in the table. In the table, they don't have any decimals. So I went ahead and I did the whole number here, 4,177. We probably could have followed their lead back here too and just done 13.7 feet since they rounded to 1 decimal place in all of these. I'm not too worried about it, to be honest. Okay, so for number 5, it says, which of the following is best modeled by a quadratic function? So keep in mind the parent graph for a quadratic function is y equals x squared. So it's relating something. You have, it's basically relating something to x squared. It's relating an area to like a side length multiplied by itself. It's squared, right? Does that make sense? It's something squared. So the relationship between circumference and diameter. Does anyone remember? So this is talking about a circle. Does anyone remember what the formula is for circumference of a circle? Diameter pi, or 2 pi r. 2 times r is diameter. So if you were to talk about the circumference of a circle and the diameter is the length across the circle. The circumference of a circle is basically the perimeter. Are you relating something in the second dimension, like an area, with like an overall? No, you're not. So we're going to say not A. That's relating a length and a length. We have nothing in 2 dimensions, nothing that has to do with area. The relationship between the area of a square and the side length, that would be a great example. The relationship between the diagonal of a square and a side length. With this one think the Pythagorean theorem, the diagonal of a square. If you got, this relates a little bit back to math too as well. I'm going to tell you guys why it doesn't work. If you have a square, if these 2 sides are the same, then the length of the diagonal is the square root of A. And so these do not relate because instead of being a squared, it's a square root. So we're going to say no to this relationship as well. And then relating the volume of a cube and the side length, that one's going to be no because it's something cubed related to a length. And so that one doesn't work as well. So the correct answer there is relating the area of a square to a side length. Okay, let's go ahead and try number 6. And then this will be, I think, probably the last one that we'll do together. I'm guessing you guys do not have graphing calculators at home. Except Desmos is not going to work the same, so it's going to be like a no homework tonight, and you guys are going to work on this tomorrow. So let's go ahead and finish this one up. Let's do this last problem, and then you guys will be have a homework-free night. So we're going to clear the calculator. All right, and we do not need the r squared this time, so we're going to skip the mode function. What should we do next? Stat. Okay, plug your numbers in. Oh, no. Okay, we'll work on it tomorrow. Thanks, guys.